Good morning, afternoon, or evening, depending on where you are joining us from. And a warm welcome to all attendees at the NEMA Virtual Spring Conference 2024. It's both an honor and a privilege to be the first keynote presenter at this esteemed event. I hope you all can see my PowerPoint screen okay. Now, today we are here to explore a topic that is not only vast, but also brimming with untapped potential. The whole life value of data in architecture, engineering, and construction and operations industry. Given the breadth of this topic and the session today will hopefully serve as an introduction, providing an overview of its importance, relevance, and practicality, and how technologies such as digital twins act as enablers. Together, let's begin this exciting journey of discovery, understanding, and application. Let's get started. Before we delve into the presentation, allow me to introduce myself. My name is Siva Koppula, and I'm currently working with Autodesk as a digital twin adoption specialist. My professional journey includes a variety of roles within the AEC firms, GIS, and BIM industries. In my current role, I actively collaborate with our customers to guide them through their digital transformation journeys. I focus on harnessing technologies such as digital twin, going beyond the hype cycle, and providing practical implementations around asset information management, property management, and sustainability, among other use cases or other areas. So, what is whole life data? So, whole life value of data considers a building's entire lifespan and covers all the phases from design to demolition. Data becomes an asset, providing valuable insights throughout the project lifecycle. Whole life value of data isn't just about collecting data, though. It's about understanding how data can inform every stage of building's life. By capturing data during design, construction, and operations, and emphasizing on the continuity of data throughout assets' life, we can gain valuable insights that improve decision making, optimize building performance, and contribute to objectives such as sustainability and social well-being. While cost seems to be the primary driver in the AEC industry, whole life value of data considers other aspects as well, such as environmental, sociological, and cultural, among others. So why is adopting a whole life value approach to data so crucial? We recently partnered with IFMA, International Facilities Management Association, and undertook a survey involving a diverse set of owner-operators. The findings were quite revealing. A significant 85% grappled with issues related to fragmented data and poor data quality. This data fragmentation and quality issues led to other challenges, including inefficient space utilization, maintenance issues, and energy wastage. These problems are largely, if not predominantly, due to the absence of a whole life approach to data. Instead of considering the entire life cycle of a built asset, many have siloed or tunnel vision approach. This narrow focus fails to consider broader objectives and overlooks the importance of upstream and downstream workflows. In other words, by not adopting a whole life value approach, we are missing out on the opportunity to utilize data in a way that can help us optimize various aspects of our operations and contribute to a more sustainable and efficient built environment. This is why we must shift towards this comprehensive whole life approach to data. Now, there are several main methods supporting whole life value approach. These include whole life costing, which focuses on financial sides, the life cycle assessment, which looks at the environmental impacts. Multi-criteria assessment is used alongside whole life costing and life cycle assessment, and value management to look at different options based on what stakeholders think is important. Value management and risk management are used to help get everyone involved in making decisions for the whole life value. Integration methodologies are important to make all of them work together. Key things to consider for whole life value include who the stakeholders are, how it affects the environment, what happens at the end of its life, the cost, how it works, how well it performs, and how long it takes and what are the risks involved. Now, let's examine some of the obstacles that impact the adoption of whole life approach to data. Implementing such an approach comes with its own sets of challenges. A key issue is the lack of awareness about the concept, methodology, significance, and benefits of using a whole life value approach for data. In addition, privacy concerns are a major consideration, emphasizing the need for responsible data usage. A shift in attitude is necessary where data is recognized as a valuable asset and the workforce is trained to harness its potential effectively. While there are some initiatives from the public sector that advocate for whole life value approach, more actions are needed. This involves providing a stronger mandate and offering greater incentives to encourage the adoption of whole life value approach to data. There are also process-related challenges such as fragmented workflows that narrowly focus on individual phases of work. This largely stems from lack of oversight of the whole life value approach, as well as constraints in time and budget. While there is growing recognition of the need to involve a broader group of stakeholders, the process and mandate for doing so remain unclear. Questions like who is responsible for including different stakeholders at various stages of the life cycle, who defines their roles and responsibilities, and who facilitates these stakeholders still need clear answers. Due to this lack of clarity, the needs of different stakeholders are not fully considered in the current approach. Also, technology is evolving very fast. We use a lot of different technologies in our buildings, right from conception, planning, to all the way to decommissioning and demolition. This can be overwhelming and prevent people from taking part and making useful contributions. For example, it's not fair to expect a facility manager or a sustainability manager to know how to use complex BIM software or even to understand the nuances of BIM data. The large number of technologies cause integration challenges as well. As a result, we end up with lots of point solutions, which create a complicated technology landscape that's hard to understand even for people who are good with technology. Another issue lies in the frequent need to monitor and update the facilities due to regular changes in the buildings, presenting a significant challenge for keeping them updated. So now let's look at some of the opportunities we can use to address these challenges. We can tackle them by employing practical measures by initiating awareness programs. For example, forums such as NIMA could be used to expound the concepts, process, and benefits of the whole life value of approach to data. There is a need to undertake pilot projects to identify, validate best practices around whole life value methodologies. These should be benchmarked, and case studies of lessons learned and best practices should be documented and shared across various sectors. Additionally, there should be emphasis on educating and influencing both public and private sectors, including owners. These efforts would aim to help them draft policies, guidelines, and mandates, as well as to foster innovative and best practices that encourage the adoption of a whole life value approach. Defining the data requirements and workflows at each phase of an asset's lifecycle are crucial. Workflows must be established that allow for smooth transition of this data from one phase to the next, ensuring that all relevant information is available when needed. Each stakeholder brings a unique perspective and a set of requirements to the table. By involving these stakeholders early and throughout the process, we can ensure that the data collected and workflows established meet everyone's needs. Change management workflows are essential for managing project changes, ensuring documentation, evaluation, and approval before implementation. Data validation workflows maintain data accuracy and completeness, while digital handover processes ensure effective data transfer between teams or phases of the project. It's also crucial to simplify the process of collecting building data throughout its life cycle and reducing the technology barrier. If technical expertise is a prerequisite for data contribution, it creates bottlenecks and hurdles in the process. To address this, user-friendly tools for data collection could be developed. For instance, it would be more efficient if suppliers of assets or equipment could directly update relevant information in a digital system rather than handing over documents and information to be incorporated into the system by, for example, BIM specialists. Digital twins can be utilized efficiently to achieve this and perform data quality checks. Maintaining a comprehensive and accurate record of building's history is vital. This tracking data about a building from design and construction to operations and maintenance. Automating data updates and simplifying integration of data from diverse sources can make this task easier. Today, digital twins automate the data update process and significantly reduce integration effort. Another key area is the use of artificial intelligence or AI, and there's an entire session dedicated to this topic as part of this NIMA virtual conference. I encourage everyone to watch the session for gaining better insights. Digital twins and AI can be used to create a more user-friendly and human-centric approach, reducing the technology barrier. So what is a digital twin? A digital twin, in simple terms, is a virtual replica of a physical entity, such as a building. It operates based on data gathered from sensors and can even be utilized to manage the physical asset. It's much more than just an intricate 3D model. It's a two-way data pipeline that enables bidirectional data transfer between the digital twin and the physical entity and the several IT and OT systems that are part of the physical entity or ecosystem. Digital twins pave the way for a digital thread, also called as golden thread, meaning those accountable will have easy access to reliable, current, and accurate data spanning through the entire life cycle of the facility. This empowers them to both execute and showcase their compliance with legal obligations. Now let's start by looking at an example. The building you see is Autodesk's Toronto office. Using Tandem, we can review real-time and historical data from the building management system. So here you can see a time series chart from an equipment data, and you can also set up threshold values. And then if the data exceeds the threshold values, you get notified through an email or through a message, or you can visualize them on the digital twin itself. We can even use intuitive tools like search and heat maps to find and identify affected spaces. And here we can see the affected spaces based on the sensor reading from a particular thermostat or a VAB. We can then look at the systems in context. So here we can identify a system based on the assets or the elements that are part of that system. And then we can even trace the system to understand critical components along its route. We can also then view the system in the first-person view so that it looks as if you're virtually in that facility, and you can walk through the facility. And then along the system, we can look at the system in context and drill into the equipment details, open O&M manual to review specs, and use that information to take corrective course of action. This is just a very, very short glimpse of what you can do with digital twins. So digital twins can play a significant role in supporting the whole life value approach. They promote enhanced decision-making due to speed of access and ease of access to the information. This information can be accessed remotely and in real time by authorized users. Digital twins enable predictive maintenance by continuously monitoring assets condition and performance using sensors. This proactive approach to maintenance helps optimize the asset's performance, minimize downtime, and extend its useful life, thereby maximizing its whole life value. Achieving sustainability goals by optimizing energy usage through real-time monitoring and more granular measurement of energy consumption, embodied carbon, and operational carbon. We can simulate different scenarios and analyze their impact on performance costs and sustainability. Digital twins facilitate continuous improvement by providing a feedback loop of data and insights. It truly offers a data driven approach to identify areas for improvement and implement changes to enhance whole life value. Digital twins simplify the technology complexity by offering an easy to use web based interface, eliminating the need to download or master complicated software, thus reducing the technology barrier. As a result, they enable a broad spectrum of stakeholders to participate at the relevant phases of the project. They promote increased collaboration among diverse group of stakeholders, integrating whole life value data such as sustainability, health and safety, social and cultural aspects, in addition to design and engineering data through design phases of the through the different phases of the built asset. Furthermore, digital twins facilitate early involvement of stakeholders, which promotes informed decision making. This early engagement and enhanced interaction builds trust in the data, minimizing delays during data handover and improving upstream data usage. So, in conclusion, I would like to say the whole life value of data presents a significant opportunity for the AECO industry. By embracing this approach and leveraging transformative technologies like digital twins, we can design and operate buildings that are not only functional, but also sustainable and resilient. The key takeaways for me would be to educate and influence owners, public sector, and private sector to draft policies, guidelines, and mandates, encouraging innovative and best practices for the whole life approach. Involve relevant stakeholders and develop processes clearly defining their roles and responsibilities to achieve beyond financial goals such as sustainability, improving quality of life, net zero carbon, and so on. Focus on use cases beyond financial goals and, and using emerging technology such as digital twins and AI tools to develop human-centric approach and simplify the use of technology across the whole life value of the asset. Finally, I would suggest visiting our website, intandem.autodesk.com, to sign up and try the digital twin for free, access other digital twin related resources, and learn more about digital twins. You can also register for our webinars if you're interested. Thank you for listening. And now we go into the next session, next part of this seminar.